welcome to my channel, Code with Fernando. So continue this series of videos. Today we are going to see the structures of a Java class and a source code file. What is a Java class? Let's see a Java class like a blueprint, okay? So it defines how objects are created and what they can do. Other interesting way to see a class is like a recipe. Like any other recipe, you need ingredients. In this case, ingredients are going to be the instance variables. So also you need ingredients and you need steps. Steps are the methods, or also called functions, in order to create something. Then we have what is a source code file in Java? Well, it's simply a text file in which we can write our Java code. Which is interesting is this file must have that Java extension. So always remember that this file in which we can write our Java code must have that Java extension in order to work properly. How to write any Java code? First of all, we need to create our that Java file in our text editor of any ID. Okay, in that we can write a class, interfaces, enums, whatever we need to create. Okay, then we have, after that, we compile our that Java file into bytecode. And who is the responsible for that? The Java compiler. So the Java compiler is responsible to take that Java file and to convert that file into bytecode. So the compiler reads the source code and checks if there are any errors. If there are no errors, the compiler converts the source code into bytecode, okay, which is saved in our that class file. So first we have that Java file. After the compiler does its work, it's transformed into that class file. Okay, so the bytecode is platform independent, so it is low level code that the Java virtual machine JVM can understand. So bytecode allows our program to run on any device that has JVM. So which means that any computer, any device that has the JVM installed can understand Java code. That's why they say Java is platform independent. After that, running the program with Java. To run the program, we use the GRE, Java Runtime Environment. So GRE is responsible to read the bytecode from our that class file, and that's also responsible to execute that file. So that GRE, the Java Runtime Environment, executes that file. Okay. What is the structure of any Java class? First of all, we have package statement. The first line in our file will be the package statement. Then we have import statement. If there are any import, maybe any library, they're going to be the imports. You can add some comments, okay? Later we are going to see comments in very great detail. Then we have our class declaration, okay? Inside our class declaration, we can have variables, methods, nested classes, nested interfaces, enums, okay? Later we are going to see in very great detail how to create a class, what is a variable, what is a method, what is a constructor also. Okay, so is there any reason to create a package statement? For sure. Okay, what is a package statement anyway? We use a package statement in order to organize classes and other code into logical structure. Okay, so let's think of a package statement like a folder on our computer. So we have our computer, we create a folder in order to organize our files. Okay, so this makes our programs more manageable, especially as they grow in size. Why use packages? Organization helps group-related classes together for better organization. So in order to work in a better way, we need to organize our files, our classes, our interfaces. So that's why we need to use packages. That's why we need to create packages. Second, avoid name conflicts. Two classes with the same name can exist in different packages without clashing. Okay, so we can have multiple classes with the same name, but they must be located in different packages. Access control allows you to control the visibility of classes and methods. So we are going to see that also in great detail. Reusable code. This makes it makes it easier to reuse classes and methods across multiple projects. Okay, so let's continue. Package statement. So we are going to see a demo, okay, for that. Okay, let's continue. I'm going to show you some code. This is a simple Java program. So I'm going to create a package. This package will be called classes. Okay, after that, I'm going to create another package called certification. Certification. So, okay, inside this package, I'm going to create another package. I know, I know, I'm going to use this package later. Yeah. Inside our certification package, I'm going to create a class called course. Okay, like I told you before, the package statement should be the first line in our file. Okay, so this is allowed. What happens if I want to do this? Put it at the end. Look, there's an error. I cannot run this program. Also, this is not allowed. Put this in the middle. No, you cannot do that. Okay, the compiler will not allow you to run this program. So that's why it should be the package statement should be at the beginning of that. Okay. Okay, let's continue with import statement. Classes and interfaces within the same package can directly reference each other without using the same package name. This means you can have classes and interfaces in the same package and you don't need to use the package name in order to use them. Okay. However, to use a class or interface from another package, we must specify its fully qualified name. It goes like this: package name, that subpackage name, that class name. There is an example in here, the string class. Okay, so the string class belongs to the Java package dot lamp package. Then we can find the string class. Using fully qualified names repeatedly can make code harder to read. So to simplify this, we can use an import statement to refer to a class or interface by its simple name. Okay, here we have university package. Inside that we have annual exam class. On the other side we have certification package. Inside that we have exam question package. Okay, if we want to make use of exam question class inside annual exam class, we just mention, and the import will be automatic. So let's continue. We have annual exam class, but this class is totally different like the other one. Okay, then we have certification package. Inside we have exam question. Also, we can make use of exam question inside this annual exam class. The code will not compile because an import statement can be placed before a package statement. Okay, we have certification package. Inside certification package, we have a class. This class will be called exam question. Then we have another package. This package will be called university. Okay, inside this package, we will create annual exam class. So if I want to make use of exam question, inside here, I just mention, right? And you see this import is automatic. You don't need to write this. Okay, so what would happen if I have another class called annual exam, but is located in a totally different package? Will I be able to use the same like this? Okay, let's check that. I am creating another exam class, but in totally different package. This class is located inside classes package, outside certification and university package. And can I use a exam question class? Sure, I can use that. Okay, then what happens if I move this statement to the end? I will not be able to run the code, right? Okay, also if I put this inside our class, also we cannot do that. So it should be the first line, okay, in our code.